In this video, we're going to name molecular elements and molecular compounds. We'll also learn how to make their formulas from their names. So a quick recap before we begin. We'll discuss molecular compounds first. We can also call molecular compounds covalent compounds. And so a molecular compound is a compound that's made up of two or more different non-metals. And they need to be different. So for example, H2O is a molecular compound because it's two different nonmetals. There's H and there's O. Whereas something like H2 is not a molecular compound. It's something else called a molecular element because it's two of the same nonmetals. So we're dealing right now with molecular compounds. The elements in molecular compounds are connected by covalent bonds. And that involves, again, the sharing of electrons. And you learned in the previous unit that you could have single bonds, double bonds, triple bonds, and there's different amounts of sharing happening. You also learned that some of the bonds can be polar or non-polar, depending on the degree of sharing. But nonetheless, it's still the sharing of electrons. As you can see here, water and oxygen are sharing electrons to complete their valence shell. And so this is different from ionic because here there's a share, whereas in ionic compounds, there was an ionic bond, which is a transfer that's happening instead, and then there's ions that form. The other thing that's a bit different here is that molecular compounds can actually exist as molecules. They don't have to exist in crystals. So you can have an individual water molecule like this, as opposed to a crystal lattice structure. But most important part is that they're made up of two different nonmetals and that they're connected by a covalent bond. So when we name these types of compounds, we use different naming rules than ionic. So when you have a problem set that has a bunch of compounds for you to name, you need to recognize first if you have ionic or molecular. And so if we're looking through this list here, the first thing we're going to do is take a look at if we have any metals. Doesn't seem like there's any metals here. So we only have nonmetals. And because we only have nonmetals, we're going to use our non-metal naming rules, our molecular naming rules, which means we need to use Greek prefixes. And so what we do is we name the elements, the first element without changing it. So the first element in this compound is nitrogen. And then we name the second element, but we change its ending. I'm going to leave a bit of space here because we're not done after this. Oxide. Now, in the case of molecular compounds, you have to use the Greek prefixes to illustrate how many of each of the atoms you have. You didn't do this in ionic compounds, but we're doing this in molecular compounds. So here we have two nitrogens, and based on the Greek prefix, that is dinitrogen. And then for the oxygen, there's 5 of them. And so based on the Greek prefix, that is penta. So dinitrogen pentaoxide. Now, the rules will apply the same way for most of these, with the exception that if the first element is 1, you don't use mono. You can use mono for the second element, but not for the first element. That's one of the main rules that we can see over here. So in this case here, you can pause the video and try it out yourself, but we would have something along these lines here. We have 1 phosphorus, but I don't put mono because it's the first element, so this is phosphorus. And then we have 3 chlorines. So that's trichloride, because we changed the ending of the second element. So change the ending of the second element, similar to what you would do in ionic. Now let's try this one. Again, 1 phosphorus, so phosphorus. We don't use mono because it's the first element. And then we have not tri. Whoops, I'm still thinking about the previous example. This time, we have 5 chlorines or chlorides, so pentachloride. Now let's try the last one there. So here we're going to use our prefixes again. So we have 2 nitrogens, so we have dinitrogen. And we have 1 oxygen, so we can use mono here because it's the second element. So I want to be clear here. So if we're writing monoxide, we're not going to put monooxide because it's kind of weird when you have these repeating vowels like that. So we just cross one of the O's out. So it's dinitrogen monoxide. monoxide. So that means we have 2 nitrogens and 1 oxygen. Another practice example you could do is this one here, so CO2. And so this is something you probably already know just based off memory, but it's where we use the rules for molecular compounds to name it. So this would, for example, be carbon. We don't use mono because it's the first element, and then dioxide. Whereas here we have CO. This is carbon monoxide. And here we have C little o. What's this? What would that compound be? That's a trick. That's not a compound. That's an element, right? One uppercase, one lowercase. This is cobalt. So be careful with that. Carbon monoxide has a big C, big O. So that was how to name molecular compounds using your Greek prefixes. And now we're going to see how to go from name to formula. And it's very easy because you don't need to do any crisscrossing and you don't need to do any reducing. You just need to make sure that you identify how many of each element you have. So you don't have to do this work every single time, but just to show you, we have dinitrogen trioxide. So the di means we have 2 nitrogens, and the trioxide means we have, well, 3 oxygens. So all we do is we do N2O3. No crisscrossing, just put what the word's saying. Put what the words are saying. So nitrogen nitrogen trifluoride. There's no mono in the front here. There's no prefix at all. So that means we have 1 N. Trifluoride means we have 3 Fs. So it's simply N. You don't need to put 1 there because it's implied. F3. Carbon dioxide. No mono there, nothing there. So we know it's 1C. Di, 2 O's. So CO2. Carbon monoxide. No prefix there. So we know it's 1C again. Mono, monoxide, 1O. CO. Triantimony nonachloride. That one's a bit different. So antimony in your periodic table is SB. Tri. There's 3 of them. Nonachloride, Cl. Nona. What is that? That's 9. Just below deca, which is 10. So there's 9 Cls. So this is SB3Cl9. No crisscrossing, no reducing. We don't reduce because these molecules actually exist as molecules. They're not in those crystal structures all the time necessarily. You can actually have an individual CO2 molecule. So that's why we don't reduce. We're not going to divide this by 3 at the end. We leave it like that. So do not reduce when it comes to your formulas for molecular compounds, and do not do crisscross either. So before we end this video, I'm going to show you a compound, and I want you to tell me what the error is in this name. Actually, let's not do that one. Let's do MgCl2. So magnesium. This is a student who writes this on a quiz. And I put an X. What's wrong with it? I mean, I'd give more feedback than that, but what's wrong with this one? So pause the video, try to think about it. Okay, so hopefully you would have said, well, I know the problem. It's this di here. This is just magnesium chloride. I don't use this for ionic compounds. We don't use the Greek prefix for ionic compounds. Now let's say I ask a student to do this. I ask a student to write a formula for dinitrogen dioxide. Oops, dioxide. And the student does this. The student starts off great and then gets this. Try to find what the mistake is. Good. So you notice that this is a molecular compound. So don't reduce for molecular. And so it should have stayed as N2O2.